Welcome back, students. After your graph arcade, I've decided to do the equilibrium chapter because some of the students have been requesting for this. So I felt I'll first do the formulas which are very important for you to remember in the equilibrium chapter, and then come back to the questions which are related to that. So when we speak about equilibrium here in your grade you have grade 11th, you are supposed to learn, or you have two types of equilibriums to study, right? That is chemical equilibrium as well as ionic equilibrium. These two are the concepts which are there. Let us see what are the different topics which are there in chemical equilibrium which you need to remember for your entrance exam too. So in chemical equilibrium you are going to study about concepts like, the first concept which we are going to learn is Henry's law. Okay, Henry's law is a concept which you need to study. Here you're going to study Henry's law in terms of two things, because numericals will be given based on two things. One is mass, relation of mass and the pressure of the gases, right? Next would be relation between mole fraction and partial pressure of the gases. Both the things I'll be dealing. And after that you are going to study about a concept called law of chemical equilibrium. So in law of chemical equilibrium we are going to study about different equilibrium constants. The first equilibrium constant, okay, let us write that. You're going to study about equilibrium constant. Just now as I said, that equilibrium constant is denoted by Kc, equilibrium constant. Done. Suppose if you have homogeneous gas phase reactions, that means all are in the same phase. Homo means similar, homogeneous gas phase reactions, but they are in gaseous state, right? They state all are in the gaseous phase. So homogeneous gas phase reactions were such, the equilibrium constant is taken as Kp. Done. Now next, if I have to speak further, you also have to study the relationship between Kp and Kc. Both the relations I'll teach. After that, next you have relationship between Kp and Kx. Now what is this Kx? Kx is, or when Kc is represented in terms of mole fraction, then we call it as Kx. Simple as that. I'll show you that also. So Kc represented in terms of mole fraction, then we call that equilibrium constant as Kx. Done. Yes, the next type which you are supposed to study is called reaction quotient. Reaction quotient. So reaction quotient, or it is also called as concentration quotient. We also call it as like, if I have to name it in this term, it is represented by Qc or Qp or simple Q. Anything will do. Okay, reaction quotient, concentration quotient, Qc, Qp or Q. Right? These are the different options. Now, apart from this, you are also going to study in chemical equilibrium. What is this number? This is 5, isn't it? Now, you're also going to study about a concept called Gibbs energy. So, in Gibbs energy in chemical equilibrium, this is what you're going to study. In Gibbs energy in chemical equilibrium, it is denoted by delta G. The same Gibbs energy, suppose if you are 5, this is 6, isn't it? So the same Gibbs energy, if you are studying under standard conditions, so then we call it as Gibbs standard, or under standard conditions, as I said, it's called standard Gibbs free energy. Standard Gibbs free energy. It is denoted by delta G naught. Okay, right. And along with this, you're going to study a concept called significance of G naught or delta G naught. Done. Next important thing which you are going to study is Le-Chatelier's principle. Most of the questions are asked from this. Le-Chatelier's principle. Okay, this is the concept. So all together these make your chemical equilibrium. Then let us come back and start with your ionic equilibrium. Let us see the concepts. Right, now let's come back and see what are the concepts which you should remember in ionic equilibrium. Basically all the ARENES, this one concept, Bronsted-Lowry concept, Lewis acid concept, all these come under this concept, this particular subtopic. So let's write what are there. So first of all, whenever you speak about ionic equilibrium, the first concept which you should learn is Oswald's dilution law. Oswald's dilution law, right? You know, after this we'll also be studying, and when you're studying Oswald dilution law, we'll speak in terms of alpha. What is alpha? Alpha is nothing but degree of dissociation. right? Degree of dissociation. So I'll just tell you what this and how to remember the formulas. Then next you will be learning about Arrhenius concept. Arrhenius concept. Next I'll be teaching you about Bronsted-Lowry concept. I'll be telling you what to remember for the exam, right? And detailed explanation will be given later when I do your grade 11 topic, right? So now after this you'll be learning about Lewis acid and bases concept, right? After that you'll be learning about hard and soft acids. Then this follows relative strength of acids and bases. Relative strength of acids and bases. Right. Now, next important concept, you're going to study about ionization constant. So, under ionization constants, you will be learning about two things. One is Ka, one is Kb. This is ionization constant for an acid. This is ionization constant for a base. Then after this concept, you'll be learning about. And you will also be learning about, after ionization constant or Ka and Kb, you'll be learning about ionization of, in this only subtopic, ionization of polybasic acid and polyacidic base. And I've changed this, polybasic acid. Second thing will be polyacidic base. Correct. Now remember, let me come back to next topic. A bit more number of topics are there in this. Now in the same thing, you also going to study, after learning the polyacidic lesson, you'll come to a concept called solubility and solubility product. Solubility product, which is denoted by, solubility product is denoted by KSP. Okay, right. So after solubility product in this one, we'll be coming to the next topic, which is important, very important, that is common ion effect. Common ion effect, right? Once we do common ion effect, then it's easy for me to teach you the concept of ionic product of water. So I'll be teaching you about ionic product of water. Then we'll be completing almost the chapter with pH scale, pOH scale, right? Again, like numericals based on that. And the last topic for you for the chapter would be, last but one topic would be salt hydrolysis. Salt hydrolysis and pH of their solutions. Right. The last topic would be buffer solutions. Buffer solutions. Under this buffer solution, we'll be studying about acidic buffer and basic buffer. Right. Let's come back and learn first the formula of Henry's law. So basically, whenever you are doing or solving numericals based on Henry's law, two formulas you need to remember for your numericals. The first formula is the formula which is relating mass and your pressure. Okay, let me write. Mass is directly proportional to pressure. So when I take out the proportionality constant, m is equal to kHp. That is the first thing. Second is, if you are taking, now here let us write what are this. This is your mass of a gas dissolved per unit volume of the solvent, and P is the pressure of the gas in equilibrium with the solution. Okay, right. Once again, mass of the gas dissolved per unit volume of the solvent at a given temperature, and this is the pressure of the gas which is in equilibrium with the solution. Done. Now the second concept, when I have to take the second formula which you should remember is, suppose if you have a mixture of gases, like if you have mixture of gases in equilibrium, mixture of gases in equilibrium with liquid, you have equilibrium between gases and liquid, then you will speak in terms of mole fraction. Then it is x is directly proportional to P, x is equal to kHp. This is the formula. So here this is different. What is the difference here? Here you have a gas per unit volume of the solvent. Means the condition you are speaking about gaseous only. Here you are going to speak about gases in equilibrium with the liquid. So these two are the formulas which you will remember, where I'll be doing different this one also, some numericals also based on this. Now let us come back and see the next formula. What is the next formula? You're going to learn about law of chemical equilibrium. So in law of chemical equilibrium, we'll be learning about, yes, law of chemical equilibrium. Suppose if I have a reversible reaction, like A combining with B or together forming a product C plus D. The coefficients of this is represented by small a, the coefficient of B is small b, coefficient of C is small c, and coefficient D is small d. Right, now if I have to write or find the equilibrium constant for this, now this is rate of forward reaction and this is rate of backward reaction. Right, suppose if I take rate of forward reaction, it is represented by RF, which is equal to a constant Kf into A by B, this one. If I have to write the rate of the reaction for the backward reaction, I'm going to write it as RB, KB, C raised to the coefficient C, and D raised to the coefficient D, small d. Right, now I have both RF and HF. Now at equilibrium, what will happen? Kf will become equal to Kb. So let us write at equilibrium Kf will become equal to Kb. This is understood concept, right? Both forward and backward reaction. Now the ratio of these, that is the ratio of Kf by Kb, is called Kc. This is called equilibrium constant. Equilibrium constant, right? What is it equal to? Kc is equal to ratio of the product C raised to the power of C by ratio of D raised to the power of D, coefficient by A, which is raised to the power of A, and B, which is, so this is called your equilibrium constant. So Kc denotes equilibrium constant. After equilibrium constant, let us see one question based on equilibrium constant, equilibrium expression also. Right, they've given us here P4. Okay, you have to be very careful while seeing the states here. So phosphorus solid state combines with oxygen in gaseous state, which is an equilibrium state, and form P4O10 solid. They're asking us what is equilibrium constant. Answer for this, whether this one, this or this. So normally when we do, we tend to write the products by the reactants, right, which is raised to the coefficient, which is raised to the coefficient. Right, here they've written product by reactants. Okay, here also product by reactant, but the coefficients are not raised to its power. Here they've taken for oxygen, here they've taken 1 by oxygen. Now according to me, for such questions, first important concept which you should remember is, whenever you have reactants in a solid state, yes, remember, for solid state the molar concentration are taken as 1. Remember the most important concept. What is that? For solid state, molar concentration is taken as 1. Okay, 1. This is the most important thing which you have to remember. When it is taken as 1, which is the answer for the first one, this is taken as 1 because we will not consider that. Yes, after that this is also taken as 1. What is left out? This is left out. How should I write? I have to write Kc is equal to 1 by oxygen raised to its power 5. That's it. This is the correct option. Hope it is clear. Let me come back and start with the next concept. In the next concept, when I have to teach you, I am going to teach you about the equilibrium constant. That means if you have homogeneous gas phase, reaction, okay, that means the reactants are in the gaseous phase. Done. What will you write? Then we are going to write or represent the equilibrium constant by Kp. Kc was earlier, now Kp, this is a constant. So Kp is equal to, right, product by reactants as usual, C raised to power of C, but here you are going to write a term called P. I'll tell you what it is, into P D raised to power D. Okay, you can write it inside also, and I'm just writing it here. You can write here also. Okay, let me write that there only, divided by P A. You can write here also, I'm showing that, into P B P. Okay, Okay, right? So shall we write everything inside here, this will come inside, this will come inside. Okay, this is that. Now what is this? For homogeneous gas phase reactions, the molar concentrations, are directly proportional to the partial pressures. So all this P is, the concentrations are directly proportional to partial pressure. P stands for partial pressure at constant temperature. So the equilibrium is denoted by Kp. If you find it in the gaseous phase, then you can take it as Kp. Done. And now next important thing, we're going to learn a relationship between Kp, that is the equilibrium constant in the gaseous phase, and Kc, the equilibrium constant, right? So when I have to write about this, let me take an example first. So first of all, I have a reaction A combining with reactant B. It's in the equilibrium state with reactant C and reactant D. Small a, small b, small c, small d. Correct? Yes. Now according to Kc, what should I write? Equilibrium constant, product, correct? Product raised to C, product coefficient D, reactant raised to its coefficient, reactant raised to its coefficient. This is your Kc. Now when I have to write about Kp, how will I write for this, right? So now what is this? Since partial pressure is equal to PV is equal to nRT, like that, PV is equal to CRT. This is the concept, isn't it? So I'm going to write in terms of this. So now how will I write? The molar concentration. Okay, let me put this C, right? Let me take this as a square bracket, C RT raised to the power of C. Next one, D, because this C is this. Now D RT raised to the power of D divided by, this becomes capital B, close bracket, RT raised to the power of B. This becomes capital A, RT raised to the power of A. Right, so now what can I take? I can take this as common, and what will I do? I'll take this whole concept as, like, if I have to take it, C, D, A, B, A are common in both, isn't it? So what is extra? I can write it as C raised to the power of C, D raised to the power of D divided by B. This is common for both, isn't it? B, this is again B, which is now into RT, C plus D, because they become, we have studied in kinetics, you add the powers, isn't it? C plus D minus A plus B, right? Yes. So now let me write. I'm not yet completed. Let me finish it off. Now, if C plus D minus A plus B is capital N, so delta N. If I write like this, then how can I write? Kp is equal to Kc RT delta N. That's it. This is the relationship between Kp and Kc. This formula you need to remember careful. Now let me teach you one more formula. Relationship between Kp and Kx. Now we are representing Kc in terms of mole fraction, right? So now when I have to write for such things, how do I write? The same reaction, A plus B giving that Ca plus B forming C plus T. The coefficients are small b, small c, small d. Now for them we are going to represent Kx in terms of Kx. Now you will write it as mole fraction X raised to power C, mole fraction D raised to power D divided by mole fraction B raised to power B, mole fraction A raised to power of A, right? So now what can we further write? I need to relate both, isn't it? So how am I relating? We very well know partial P, that because I need to compare that partial pressure. Partial pressure is equal to mole fraction into total pressure. We have studied this in relative lowering of vapor pressure colligative properties. We have studied this function, isn't it? Partial pressure is equal to X into P, mole fraction into capital P. So what can I write now? The same thing. If I take Kp is equal to Kc, we already have this equation earlier, isn't it? Kc delta N, okay, then Kp is equal to Kx into RT delta N. That's it. Simple, isn't it? I can also write this as G. Why am I writing this G? This G is equal to, it is number of moles of the gaseous products minus number of moles of the gaseous reactants. Remember this. One more formula for you. Kp and Kc is this formula. Kp and Kx is this formula. So both the relations, please remember. Right, now we have seen the relation between Kp and Kc. We have also seen the relation between Kp and Kx, isn't it? Now, let us see or note some important things which are very important for your listen. So now what should you remember? If delta Ng, okay, Ng is equal to 0. Same condition, delta Ng is positive. Delta Ng is negative. I told you what is Ng. Ng is the number of moles of the gaseous products minus number of moles of the gaseous reactants. Yes. So now, if delta Ng is 0, then condition is Kp is equal to Kc. If delta Ng is positive, the condition is Kp will be greater than Kc. Just hope you understood this Kp and Kc. Then delta Ng is negative, then Kp is less than Kc. Remember this. Now let us write the units for Kp and Kc. So for Kc, the unit is mole per liter. Delta Ng, unit for Kp is atmosphere. Delta Ng. Remember this. So units are also there, relations also there. It is easy for you to do the numerical. Now let us come back and learn the next topic, that is Gibbs energy in chemical equilibrium. Right. So whenever you are speaking about Gibbs energy, two important things you have to remember. What are they? You need to remember the formula for delta G as well as delta G naught. Both the things you need to remember. So what is this delta G? Delta G is change in Gibbs energy. This one, right? What is delta G naught? Delta G naught is the standard Gibbs free energy change. Okay, this is standard Gibbs free energy change. This is change in Gibbs free energy. Right. The formula for this is delta G is equal to delta G naught plus 2.303 RT log Q. So this is what is the thing, and when I have to speak about delta G naught is equal to minus 2.303 RT log Kc. I can also write this as 2.303 RT log Kp, because we have related between Kc and Kp. Yes, or I can write it as Kp is equal to anti-log minus delta G, same thing, by 2.303 RT. That's it. These are the formulas. So it gives energy, these two formulas, you will be using it in different numericals. Done. Now next important thing, very important concept of Gibbs free energy, that is significance of delta G. This is where they'll ask you whether the reaction is feasible or not. You have to remember this. Significance of delta G naught. Let us write. Now suppose, let us write the condition 1. If delta G naught is less than 0, first condition. Second condition, if delta G naught is greater than 0. Third condition, if delta G naught is equal to 0. Fourth condition, if delta G naught has very high positive value. Fifth condition, delta G naught has very small positive value. Very high positive value and very small positive value. What is this condition? Now if delta G is less than 0, right, that means the reaction will be a forward reaction and it is spontaneous after calculating from the sum. Spontaneous. Now, if it is greater than 0, backward reaction is favored. Backward reaction is favored. If it is equal to 0 after solving, that means it represents an equilibrium state. Equilibrium state. Right. If it is very high positive value, that means K is very much greater than 1. That means the forward reaction is almost complete. Forward reaction is nearly complete. Nearly complete. If it is the positive value, very small value, that means the reverse reaction is nearly complete. This is what you have to remember with your Gibbs free energy. These are the cases which you need to remember. start with the next important topic of your equilibrium, that is solubility product. First we'll understand this concept and then start doing some numericals based on this from 2002 to 2016. Right. So now in solubility product, when I have to speak, what actually is solubility product? First of all, let us understand. Now what am I going to do? I'm going to take a saturated solution. Right, so hope you all know what is saturated solution. What saturated solution of which one? I'm going to take saturated solution of sparingly soluble electrolyte. I'm going to take this. Okay, sparingly soluble electrolyte. Done. So now what is the electrolyte which I've taken? Let us name the name of the electrolyte as AB. Now, so this AB first of all is in solid state. Okay, I'm going to take this solid state. Later I'm going to dissolve this, and when I dissolve this, okay, this is dissolved. Still it is not ionized, it's still compact together. Further, when this completely starts dissolving, it starts dissociating into ions, that is A plus cation and B minus anions. Okay, these two are ions. Done. Now I have to write or take the equilibrium constant for this. K is equal to concentration of A plus and concentration of B minus divided by product by reactant AB. Correct? Yes. Now indirectly what does this mean? If I cross multiply with this, concentration of a cation into concentration of anion is equal to K into AB. Right? Done? Yes. Now if we speak in terms of this, if AB is a constant, right, we are going to take this as AB as a constant. Let us take this AB constant, which is equal to, let us assume AB is a constant and take this as K prime. Then this becomes A plus and your anion charge, which becomes equal to K prime. K prime is equal to KSP. That's it. This is your solubility product. Now what is the solubility product? This is represented as SP, means the solubility product. Now how am I defining solubility product? First of all, now again this is a new constant. This is one constant, this is one more constant, this is new constant again. How is it defined? It is a product of the molar concentrations of molar concentration of its like each ion. What ion? Molar concentration of ions. In which state are these ions? They are in the saturated solution. They are present in the saturated solution, we said? Yes. In which the concentration term is raised to the power equal to the number of ions. The concentration terms raised to the power equal to the number of ions present in the equation. So number of ions present in the chemical equation. Okay, it is again, I am defining KSP is a product of the molar concentrations of the ions. These are present in the saturated solution and each is raised to the power of their this is number of ions. Okay, what am I trying to explain this? I am trying to explain, basically, let me take an example and see. So when I have to take an example of KSP, you will understand clearly how to do this. So suppose if I have one example, right, silver chloride is one example, right, silver bromide, okay, right, or barium sulfate. Okay, all I'm taking one cation, one anion. No, for this KSP is equal to one cation, one anion, so it is 2. 1 plus 1, 2. Let us take one more example. Now what type is this? This is AB type. One cation, one anion. Now suppose if I take AB2 type. Okay, let lead chloride in that way, right? So let me take, this is example 1, this is example 2. If I take PbCl2, ZnCl2, Ag2CO3, H2S, right? So now in this particular thing, it may be like both the ratio, 1 is to 2 or 2 is to 1, both the ratios, not a problem. So then KSP for this becomes each raised to the power of their this in charge, isn't it? Right, this becomes 4s cube. Suppose if I have to write AB3 type, that is 1 is to 3 type. Examples: aluminium chloride, ferric hydroxide, all these. Here when you raise the charge of that in cubit, what do you get? KSP becomes equal to 27 s raised to the power of 4. Suppose if you take one more, where you are going to take type A2B2 type, 2 is to 2 type ratio, like SB2 S3. Here in this case KSP, if you raise the power, you will get equal to 108 S5. This is how you're going to write, right? So S is a solubility, correct? So what is the solubility unit now? Solubility is we can write it as S is equal to mole per liter. Mole per liter, right? Now this is how you're going to learn the solubility product. Simple, isn't it? Now let us come back and do one more concept, that is your lesson. Okay, let's come back and do pH scale now. So what actually is pH scale, if I have to say? Simple, isn't it? You've seen the pH meter also, pH paper also in your lab. So Sorensen has defined this pH of a solution. What is this? It is equal to pH is equal to negative logarithm of H plus ion concentration, which can be written as log 1 divided by H plus. Correct? Yes. Now if I have to write under base 10, H plus ion concentration is equal to minus pH. Done. So decrease in pH unit corresponds to 10, means if the pH unit is decreased, that means the pH unit corresponds to the acidic nature increases 10 times. Remember that if the pH value, single pH, one pH value, single pH unit decreases, that means the acidic nature increases 10 times. Okay, right? Remember this concept. Now, suppose if I have to do the POH concept, let me take POH concept. When I have to speak about POH concept, what is the formula? POH is equal to negative log of OH minus concentration, which is nothing but log, as we have written, 1 divided by OH minus. Correct. So how can I write this? I can write it as OH minus is equal to 10 folds of POH, the same concept. Now we also have studied PW is equal to pH plus POH, which is equal to 14. How many degrees? It's 25 degrees centigrade. Done. So now what should you remember? There are certain formulas which you should remember for this pH for calculating the numericals. So we'll be learning pH for monobasic acid, we'll be learning pH for monobasic base. Okay, let us write. So the first formula you should remember is pH of weak monobasic acid. Formula is pH is equal to half of pKa minus log C. Now the other way, if I have to take, I'm taking the second one. Now I'm speaking about POH of a weak monobasic base. So what is the formula? POH is equal to half pKb minus log C. Okay, the same thing which is the pK for monobasic acid. So monobasic acid we took it as pKa. For monobasic base we took it as pKb. Done. Yes, if I have to write pH is equal to 14 minus POH. What is POH? This value. So I'm going to substitute that value. 14 minus half into pKb minus log C. Correct. Now, so total value, so this is, you can use it for the numericals also. Total OH minus in a mixture of weak bases. One more formula which you can remember, which you should remember, is root Kc1 plus K root K1 C1 K2 C2. So remember this. So if you know this basic idea of pH and POH and solubility product, we'll start doing certain numericals which are given in your GE papers. Right. So with the basic formulas which we have studied for solubility product, pH and POH, let us come back and solve the numericals which are given in your papers. Now, what did they give? This particular question is picked up from AEEE 2004. Let us read this question. Here they've given us the molar solubility, that is mole per liter, as we have learned the formula of a sparingly soluble salt. Okay, that is of type MX4, AB4 is S. Okay, this, so the corresponding solubility product is KSP. The Okay, we have studied this also. S is given in terms of KSP by the relation. Okay, we have already solved for type, isn't it? AB2, AB2, B2, this one, and AB4 we have done that. So they are asking that thing, how to solve it. They are expecting us to write in relation between S and KSP for this particular thing, for MX4. Done. So let us take, for example, if I have to solve this, first of all, let me consider A, B and electrolyte. For this type I am not mentioning, A, B, X, and this is Y. When this dissociates into A plus B. The coefficients are written like this. Now when I have to write the solubility product of that, as we have defined in the definition, x raised to the power of x, y raised to the power of y, s, x plus y. You can write this also. So now let us take MX4 now. MX4 is this one which they have given us. This dissociates into M plus 4 plus 4x minus. Now here x is equal to 1, y is equal to 4. So now what is the solubility product? KSP is equal to 4, this one raised to the power of 4 and 1 raised to the power of 1. It's now the same thing, just like this. X raised to the power of x, 4 raised to the power of 4, right? Y raised to the power of y, and 1 raised to the power of 1. S is like this, 4 plus 1, that is 5. So KSP is equal to, if I have to solve this, you're going to get this one as 256 S5. S is equal to KSP by 256 1. That's it. So this is the answer which we have got. So what is the correct option for this? Now when I have got this answer, and I see not the first one, not the second one, not the third one, not the thing. This is the correct option, D. Yes. Right, let's come back and do one more numerical, that is which is like based on your if I have to say the formation or the question based on pH value. So they are asking us to find the pH value for the given thing. Let us read. Hydrogen ion concentration is in mole per liter in a solution of pH 5.4. H plus ion concentration, the pH is 5.4. Right, simple. Let us start solving the numerical. So first of all, we will write the formula. We have learned H plus is equal to 10 times pH. This is what we have said. One decrease, the acidity increases 10-fold. Correct. Now take log on both the sides. Log on both the sides. Log H plus is equal to, this becomes pH log 10. Now this carries forward, log H plus, right? So now how much is the pH given to us? It is 5 minus, that is 5.4, minus is already there, 0.4, log 10 is 1. This becomes 5.4. So now H plus is equal to anti-log, when this goes the other way, this becomes anti-log minus 5.4. You can write this as 1 divided by anti-log 5.4. So when I divide this and find the anti-log, which I have already done one video based how to find the log in anti-log. So when you get this, you get H plus concentration is equal to 3.98 into 10 raised to the minus 6 molar. Please watch that video where I have taught you how to do the anti-log part. So 3.9 into 10 raised to the minus 6. So the option is 3.9 into 10 raised to the minus 6 molar. The first option is correct. Let us come back and do one more question here, a bit linked with the buffer solutions. Okay, not a problem. Here they've given us the pKa of a weak acid HA is 4.5 and the pOH of an aqueous buffered solution of HA in which 50% of the acid ionized is. Okay, so what are they asking us? They are asking us to find out how much is the pOH of the buffered solution. So basically there are 2-3 methods to do this. I felt this this is the easiest way, applying the formula directly. Just see. So for buffer solution, when I have to take, I'm applying the formula directly and doing it. For buffer solution, we have a formula, pH is equal to pKa plus log salt by acid, which is equal to, now how much is the pKa value given to us? 4.5 plus log salt by acid. Done. Now they said if HA is 50% ionized, they said. Okay. If it is 50% ionized, then what will happen? Salt is equal to acid. Correct? 50% ionized means salt concentration is equal to acid concentration. Exactly half of that, isn't it? When you go in the pH scale. So this becomes pH is equal to 4.5 plus 0. Okay? Because this is equal to this, because 50% ionized. So 4.5 plus 0. So this becomes 4.5. Now, we very well know, since pH plus POH is equal to 14. So POH is equal to 14 minus 4.5, which is equal to 9.5. That's it. So the answer is 9.5. The correct option is this. Right. Now let us do one more numerical, which is based on the solubility product. We've already done the formula for solubility product. Let's read this. What do they give us? The solubility product of a salt having general formula mx2. Okay, this is AB2 type. In water is 4 into 10 raised to the power of minus 12. The concentration of M plus ions in the aqueous solution of the salt is, so this is AAAE 2005 question. They've given 4 options. First of all, what should I find? I need to find M plus 2 concentration, that is an aqueous solution of the salt. Let us solve. First of all, take the type of this one given to you. It is given mx2. As soon as it is dissolved, it will dissociate into M plus 2 plus 2x minus ions. So this is S and this is 2S. Now when I have to write the solubility product, we very well studied, it is a product of the concentration of the cation and the anion, each raised to the power of the ions, the number of ions, so that is concentration raised to the coefficients. Now this is the charge for this. For the x, this becomes minus 2. Now if solubility is, if we take the solubility as S, then we can write it as Ksp is equal to S into 2s. This becomes 4s cube, because this is the formula according to the definition. In that I've substituted this value which is given. We got 4s cube. So if I have to solve this, s cube is equal to 4 into 10 raised to the power minus 12, which they have given here. So if I am solving this, s is equal to 1 into 10 to the power minus 4 molar. Now I need to find for M plus 2 ion. That means for that only I found out, isn't it? So M plus 2 ion, S is equal to 1 into 10 raised to the power minus 4 molar. So the correct option is 1 into 10 raised to the power minus 4 molar. This is the correct option. Right. Now let us do one more question, which is based on finding the KSP, solubility product. So they've given us solid barium nitrate is gradually dissolved, right, in sodium carbonate solution. Okay. At what concentration of barium plus 2 will be precipitated, or precipitation begins to form? KSP for barium carbonate is given to us. Right, so this is what barium nitrate mixed with sodium carbonate, so it has formed barium carbonate. Done. So now what should I find out? I need to find for Ba plus 2 ion. At what concentration will it precipitate out? So now when I have to take about KSP of barium carbonate, why am I taking? Because these two have combined and formed this product. It will dissociate into, what will it dissociate into? Barium plus 2 cation and carbonate minus 2 anion. So normally KSP formula we have, isn't it, for the cation to anion, but I need to find Ba plus 2 now. So Ba plus 2 is equal to KSP by carbonate minus 2. How much is KSP given to me? 5.1 into 10 raised to the power minus 9. How much is carbonate given to me? 1 into 1.0 into 10 raised power of minus 4 molar. So barium plus 2, when I solve this, when I divide, I get an answer of 5.1 into 10 raised power of minus 5 molar. That's it. So this is the way. The correct option is this. Right, so we have seen the concepts and formulas which are required in chemical equilibrium. We have studied about equilibrium constant Kc. I've also taught you what is the meaning of Kp, right? So let us I've picked up certain questions which are there in from 2000 to 2016. So this is a 2010 question which is given. So let us do this question. So here they've given us in aqueous solution the ionization constant of carbonic acid is K1 is so much. Right, then they've given K2 value. Okay, then they said select the correct statement for a saturated 0.034 molar solution of carbonic acid. Right, so I need to solve this and find which is the correct one. So let us solve the numerical. First of all, they said carbonic acid. Let me take carbonic acid. This dissociates into H plus and CO3 minus, HCO3 minus. What is the Ka value given to this? 4.2 into 10 raised power of minus 7. Second, this further dissociates, HCO3 minus dissociates into H plus plus, H is carbonate minus. K2 value given to us is 4.8 into 10 raised power of minus 11. Correct. Now this said, like even though it is not mentioned, when I see the values, I'll say Ka1 or K1 is very much greater than K2. Right, so let us see. So what will we do with that instance? I'm going to take, therefore, H plus is equal to HCO3 minus. So K2 is equal to H plus concentration, CO3 minus 2 concentration divided by HCO3 minus. So what will happen now? CO3 minus 2 is equal to K2, which is equal to 4.8 into 10 raised power of minus 11. That's it. So simple, isn't it? I just did this one. I made it equalized and then finally I've written the answer. So the answer is 4.8 into 10 raised power of minus 11. So what did they give me here? They said which is the correct answer for this. So when I have to speak after solving this numerical, so after solving the numerical, what did we get? We've equalized the things, right? So what is the correct answer now? The concentration of H plus and HCO3 minus are approximately equal. With this data, I just equalized this and I finally have written X2 is equal, K2 is equal to 4.8. So the correct answer for this is this one. Let's see one more question which is based on your equilibrium constants. So here what do they give us? The equilibrium constants Kp1 and Kp2 for the reactions. There are two reactions given. X is in equilibrium with 2y, Z in equilibrium with P plus Q, right? Respectively are the ratio 1:9. If the degree of dissociation of X and Z be equal, then the ratio of total pressure at the equilibrium is, okay, they ask us to, they have spoken in terms of pressure. So now you have to be careful while solving that. You're going to take in terms of partial pressures. So let me see. Now what do they say? X is in equilibrium with 2y. Initially the number of moles of X is 1 and the number of moles of this is 0. Right? So now at equilibrium what will happen? This becomes 1 minus X and this becomes 2X. So now what will happen to the total number of moles? Total number of moles is equal to 1 plus X when you take out this. So now let us write for Kp1. Kp1 is equal to 2X. I'm taking from this side 2X by 1 plus X. This one. P1, I have written the formula also in the previous video. From that only I have written this 1 minus X by 1 plus X P1. This comes equal to 4X square by 2 square 1 minus X into P1 by 1 plus x. This is over for this, right? Now let's do the next one. What is the second one? They said the second part, Z is in equilibrium with P plus Q. Again, initially the concentration of Z is 1. The concentration of P and Q are 0 and 0. Now at equilibrium, what will happen is the concentration of this becomes x1 minus x, and this becomes x and x. Now let us write Kp2 in terms of partial pressure. The same thing, ratio if I take, I get x square by 1 minus x into P2 by the same thing. I did right, I'm directly writing it here, 1 plus x. Then I'm taking the ratio of Kp1 by Kp2, which is equal to 1 by 9. So if I take the previous one, because they have given 4, okay, 4 isn't it? Here, this one 4. So now I'm taking that 4 into P1 by P2 is equal to 1 by 9. This becomes equal to P1 by P2 is equal to 9 4s are 36, 1 by 36. So it is 1:36. So the correct option for this is 1:36. Right. So now let us do one more question, which is given in your AHEP 2003 paper. So here what do they give us? For the reaction equilibrium, they've given one reaction here, and the concentration of N2O4 and NO2 at equilibrium are 4.8 into 10 to the power of minus 2 and 1.2 into 10 to the power of minus 2 mole per liter. The value for Kc. I need to find the value for the equilibrium constant value for this. Simplest numerical, I should say. What is this actually? They've given two things, isn't it? Now what is Kc? Kc is equal to concentration, because only two are there, product by reactant. Concentration of the product raised to its power by concentration of the reactant. Right, done. How much is N? This is NO2. Okay, this is NO2, I think. Right, how much is this given? This is equal to 4. No, this is NO2 is how much? 1.2 into 10 to the power of, it will become reverse, right? 1.2 into 10 to the power of minus 2 square divided by 4.8 into 10 to the power of minus 2. When you take the ratio, Kc value will get equal to 3 into 10 to the power of minus 3 mole per liter. This is the answer. So when I have to take the correct answer, 3 into 10 to the power of minus 3 mole per liter. This is the correct answer. Welcome back, students. Now let's start with your ionic equilibrium. So first let us learn the concepts which are there in ionic equilibrium, important things which you should remember for your exam, and then we will start with solving the questions based on this. Done. So in ionic equilibrium, when I have to take, first important concept which you have to remember is Oswald Dilution Law, right? So let us write the heading first. Oswald's Dilution Law. Okay, what does this law want us to learn? So in Oswald Dilution Law, the first important concept is, right, suppose you are taking a binary electrolyte. What is a binary electrolyte? So important thing, a combination. Binary means two, a combination of a cation and an anion, just like AB, right? So when you are taking AB, a binary electrolyte, when this is dissolved in water, this dissociates into A plus cation and B minus anion. So initially, when I have to take the concentration of this, the concentration of this is denoted by C, and this will be 0 and 0 because not yet dissociated. Now at equilibrium point, when it reaches the equilibrium, suppose the amount dissociated, a part of the thing dissociated is alpha, then this becomes C alpha, this becomes C 1 minus alpha. Right, now what is C? C is the initial concentration of the electrolyte and alpha is the degree of dissociation. Now when I have to write the equilibrium constant, K is equal to product by reactant, so product cation by reactant divided by the concentration of the product divided by the concentration of the reactant. Now how much is A plus? A plus is C alpha. How much is B minus? It is again C alpha. How much is AB? It is C into 1 minus alpha. Now C square alpha square, they get cancelled. This becomes C alpha square by 1 minus alpha. correct? Now when I have to take weak electrolytes, right, weak electrolyte means which will not dissociate further. It's very difficult for us to dissociate. So alpha will be very much less than 1. That means if alpha is very much less than 1, then 1 minus alpha will be 1. So what will be K left with? K is equal to C alpha square. Yes, so alpha is equal to root of K by C. So alpha, now when I have to write the formula, alpha is directly proportional to 1 by root C. This is one formula which we will be using in the sum. Why did I write this? Since concentration is inversely related to volume, right? So now this one more thing, alpha, if I have to write, alpha is directly related to root V. Yes, because this and this are inversely related, so alpha is directly related to root V. So this is your Oswald dilution law. So this is going to speak about degree of dissociation for the binary electrolyte as well as for a weak electrolyte. Done. So let us take out this. Now let us start with one more concept, that is Arrhenius concept. So in Arrhenius concept, what is Arrhenius trying to teach us? First important thing in Arrhenius you have to remember, is going to speak about acids and bases, the nature of acids and bases. Suppose if I have to take HA, right? Now I'm going to take just a base. Now I'm taking an acid with H plus ion proton. So acid, I'm taking OH minus with which one particular just like base to denote the base. This is one. Suppose let us assume this is one electrolyte, right? In that it is that particular acid with H plus ion, the minus one, the other one anion. Now here anion and cation, because this is OH minus, this is a base. Now when this dissociates in water, when the acid dissociates in water, it will break up into H plus and A minus. When the base dissociates in water, this breaks up into B plus and OH minus. Now, according to Arrhenius, now define what are acids. Acids are those substances when dissolved in water which gives H plus ions is called, or which furnish H plus ions is called an acid, according to Arrhenius. Base are those substances which when dissolved in water are going to furnish OH minus ions. Such are called bases. This is the basic explanation of this. Suppose if I have to take the Bronsted-Lowry concept. So I'm talking about the next concept, Bronsted-Lowry. So according to Arrhenius, he said which Bronsted-Lowry concept. And in this Bronsted-Lowry concept, what is here also is going to speak about acid and a base. So acid is a substance which can be a molecular ion. Suppose if I take an acid, H3OH, acid, right? So he said acid is a substance that can donate proton and base is a substance that can accept proton. Okay, that means suppose if I take acid, I am dissolving this in water, right? This dissociates into, this picks up the one hydrogen and this becomes H3O plus CH3CO minus. Now this we know it is an acid, correct? Now what is this doing? This particular thing, this is losing one proton. Now what is this doing? This is accepting one proton. Yes. Now see here, acid is a substance that is donating a proton. Now this is donating one proton to this, so it's an acid. Now what is a base? Base is a substance which is accepting a proton, either way. So acid is donating, base is accepting, correct? Now indirectly if I say acid is a proton donor, base is a proton acceptor, in simple words, right? Now let us speak about something else. Now what is this H3O plus formed? H3O plus formed, from where did this form? This has formed from by picking up a proton from an acid. So this particular thing has formed by picking up a proton from an acid. This is called conjugate acid. Conjugate acid, right? Now if it is conjugate acid, this will become conjugate base, isn't it? That's it. Now let us try speak about this. First, hope you would have understood this concept. I'm going to write some important thing which will be useful for your reasoning questions. What do I say? If I have a strong base, this will have a weak conjugate acid. And if I speak about a weak base, this will have strong conjugate acid. Remember this, right? And the reactions which involve the transfer of protons are called neutralization reactions, which you know, correct? So remember this is very important. Once again, acid which donates a proton, base which accepts a proton, the product which is formed, because it is formed from an acid, a conjugate of that conjugate acid. The other one is conjugate base. Done? Yes. Now let me speak about the next concept, that is Lewis acid base concept. Lewis acids and bases concept. So when I have to speak about this concept, simple. Till now we have spoken about proton donor, proton acceptor, and all these things. What is Lewis trying to explain? Whenever Lewis, whenever you speak about Lewis, you need to speak in terms of, now till now we spoke about proton only, but here whenever you're speaking about Lewis, try to speak in terms of electron pair only. Remember this, right? So what is he saying? Acid, he'll speak in electron pair concept only. Let me take, suppose if I am taking a particular combination of two things. Just see, I'm going to take borofluoric acid, BF3. This is an acid. I'm going to take a base, ammonia. We very well know nitrogen when I have to speak 7, 1s2, 2s2, 2p3. Correct? So this is donating 3 electrons and still has a lone pair. So dot. Now what is this base doing? This base, or sorry, what is this acid doing? This acid is accepting this electron pair. I'm speaking in terms of electron pair. Acid is accepting electron pair. So from where is this? This is basically, if I have to write, it is from nitrogen. From nitrogen, the electron pair is donated to BF3. So this acid is picking up an electron pair, electron pair acceptor. So let us write the first one. According to Lewis, acids are electron pair acceptor, EPA. Acids are EPA. Done. Now when I have to speak in terms of base, suppose I am taking a base, OH minus. This is again pair. H plus deficient, because acid requires electron pair, that's why it's H plus. Now what is happening? From OH, the electron pair is donated to H. So what is base? Bases are electron pair donors. So what are bases? Bases are electron pair donors, EPD. EPA for acids, EPD for bases. Hope this is clear for you all. Right. So now let us come back and see the next concept. Now we have studied about ARENES, we have studied about Bronsted-Lowry, we will study about Lewis acid bases. Now let us come back and study some other topic, like an important topic, that is relative strength of acids and bases. Now let us learn the concept of relative strength of acids and bases. Now to measure the relative strength of two acids, first of all we are going to measure, measure the strength of the H plus ion concentration, because I am talking about acids, isn't it? Right. Now suppose if I take the first thing, strength of, I am comparing between two acids, strength of acid 1, I am taking one acid whose this one I am written as HA1. The same thing, strength of acid 2, I am going to take as HA2. The degree of dissociation, alpha 1 by alpha 2. Already I have got a formula initially, that is equal to root Ka1 by C by Ka2 by C. This is what you have studied already, isn't it? So this becomes equal to root Ka1 by root Ka2. Simple. So hope you would have understood this. I've got this formula already, which I did with your initial one. So now when I have to speak in terms of bases, same thing. Now let us write this for acids. Now let us write this for bases. Strength of base 1 That will be B1OH. So that is base 1. So 1 for B divided by strength of base 2 B2OH. Again the same, when you derive the same thing, but here you get KB1 KB2. So finally you get root KB1 by KB2. Right? Now this is a concept. Now we are comparing relative strength of acids and bases. Now when I have to speak about the relative strength of some acids, so they may ask you in the question. So I am writing the relative strength of some acids and bases. Let us divide the page into 2 equal halves. I am not drawing a straight line, please, sorry for that. So when I have to write the relative strength, first important thing, the strongest one, that is HClO4 minus, which is greater than HBr, which is greater than HCl, which is greater than HNO3, which is greater than H2SO4, which is greater than H3O+, which is greater than sulfurous acid, which is greater than carbonic acid, which is greater than acetic acid. This is the maximum. It is this, and then HClO4. So HClO4. This one, okay. This is greater than HClO3. This is greater than HClO2. L is also there here, greater than HClO. Here we are comparing between this set. Till here this one, this again this set. When I speak about this is your acid strength. This is your basis strength. Potassium hydroxide strong, then NaOH stronger, then calcium hydroxide stronger, then ammonium hydroxide stronger, then ammonia stronger, then hydrazine stronger, then hydroxylamine bases. So these are the relative strengths of some acids and bases. Now suppose based on the relative strength, we'll also do certain numericals. First learn the concept, and it's easy for me to teach the numericals. Done. So now let's come back and see next topic. Right. So after your ionic product of water, let us learn one more important thing, that is ionization constants. So ionic equilibrium, right? That's the reason we have to learn about different equilibrium constants. Now here I'm going to speak about, for acids, if I have to take I'm going to talk about ionization constant, that is Ka and Kb. What is this? This is ionization constant of an acid. This is ionization constant of a base. Right? So what is the formula which we've written already? K is equal to alpha square by 1 minus alpha into C. If I have to take base, Kb is equal to alpha square, okay, same thing, C alpha square by 1 minus alpha. Correct? Right. So now what is this? K is ionization constant of an acid, C is a concentration, and alpha is a degree of ionization. Here also it's the same. Now when C is a constant, like if alpha is very small, if I have to speak, 1 minus alpha is becomes equal to 1. So alpha is small, very small. Degree of ionization is very small. Then 1 minus alpha becomes equal to 1. So what will Ka become? Ka will become equal to C alpha square, or alpha is equal to root of, I did the same, I'm doing it again, K. So I can write this as into root Kb. Why? Because concentration is inversely related to 1 by volume. I've written this. This is one formula which you can use for numericals. Suppose if I have to write in speak, the same thing. If alpha is very small, 1 minus alpha will be this one, 1. So Kb will become equal to C alpha square. Alpha is equal to root of Kb by C. Same thing, alpha is equal to, since C is inversely related to 1 by volume, alpha becomes root Kb. This is one more. This is one formula. This is one more formula for this. So what is V? V is the volume of the solution containing 1 mole. Correct? Volume of this 1 mole. Now the same thing, if I have to speak in terms of one more concept which you should remember, that is ionization of polyacid and polyacidic base. That means acid base equilibrium. I'm going to teach you about acid base equilibrium. Acid base equilibrium. So what is this acid-base equilibrium? Now we have already studied about, we are going to learn about acid-base equilibrium in terms of polyacid, polybasic acid and polyacidic base. Once again, polybasic acid and polyacidic base. Right. So now if I have to speak, what is this? Polybasic or polyprotic acids. Oxalic acid is a polyprotic acid. Carbonic acid, phosphoric acid, sulfuric acid. Done. So for such things, okay, let us write what we said. Polyprotic acid examples. Polybasic or polyprotic acids. Examples, if they ask you for 1 mark question, 3 marks question, polyprotic acid, oxalic acid. Oxalic acid. What is this? HCOH. Sulfuric acid, carbonic acid, phosphoric acid. All these are examples. Now, suppose if you have to speak about acid-base equilibrium, just simple. If I take phosphoric acid, and again a common example, this dissociates into H++ H2PO4 minus. Ka1 for this is 7.52 into 10 raised to -3. Again this dissociates, H2PO4 minus dissociates into H++ HPO4 minus 2. Ka2 for this is 6.23 into 10 raised to -8. I am taking this again, HPO4 minus 2. This further dissociates into H++ PO4 minus 3. Ka3 is equal to 4.8 into 10 raised to -13. Right. Now if I have to take the order, what is that? Order of dissociation constant. Order of dissociation constant. What is that? Ka1 is always greater than Ka2, it is greater than Ka3. If I have to take a base, Kb1 greater than Kb2 greater than Kb3. That's it. It goes on how many ever times till it dissociates. Let us come back and learn the next topic, that is common ion effect. So it's very simple, but I don't know, most of the students, they get confused. Let us read this. Suppose if I have to speak about common ion effect, as the name suggests, it is there in the name only. Now I have an electrolyte, right? I have a saturated, this is a quite common example which everybody takes. I am also taking it, so that's easy for you. I am taking a saturated solution of AgCl. What will happen? Silver chloride, it dissociates solid into Ag plus, which is aqueous, plus Cl minus aqueous. It's understood, right? When it is dissolved in solid, is dissolved in water. Now, suppose to the same thing, when I add NaCl to the solution, I am adding NaCl to the solution. Then what will happen? So now you are adding sodium chloride to the solution. Now this chloride ion, concentration of this will become more, it will increase. Then what will happen to the equilibrium? It will shift towards right only, because the concentration of this is more, because you added NaCl. The equilibrium will be shifted right, will increase, and the equilibrium shifted to the left. Okay, or right, let us see. Hence the dissociation, what will happen to the dissociation of this? We will see. I will explain what I am trying to say. Now, when a partially soluble ionic substance, a silver chloride, is dissolved in water, it dissociates into Ag plus and Cl minus. Now, there is an equilibrium between those two. Now, at equilibrium, now what will happen? The solute dissolves the same rate at which the ions also crystallize the salt. Correct? Yes. Now, what happened? As I said, once again I will come back. When you added NaCl to the solution, the concentration of Cl minus will increase so much in the solution. Now the equilibrium will be shifted towards left, isn't it? It will be so much, it will be shifted towards left, not towards right. It will be shifted towards the left. Yes, hence the dissociation of AgCl will decrease, isn't it? Yes, when NaCl is added due to common ion, what will happen? Due to common ion effect, the same effect, equilibrium, let us put that in inverted commas, shifts towards left. When the equilibrium shifts towards the left, what will happen to the dissociation of AgCl? Dissociation of silver chloride decreases. This is your important thing, correct? Yes. Now, so this effect is called common ion effect. Now what will happen? What is the result of this? Due to common ion effect, the concentration of the ion not in common in two electrolyte is decreased, which is because not in common, this is not in common, this is not in common. So that will decrease the concentration of ion, that particular ion. This phenomena for wherever we're using for qualitative analysis to adjust the concentration wherever you require. So if you need to find, we will adjust this concentration and we'll find this one for this, because you are reducing this and you're increasing this by adding this. So common ion effect basically is used to find the qualitative, it is used in qualitative analysis for finding the second group, and this is increased and this is decreased. So this is your common ion effect. Now when I have to speak about next important thing, that is ionization constant and ionic product of water. This is one more concept. Hope you would have understood that. So equilibrium shifts to the left in common ion effect because the amount of concentration of the particular ion is more. Now the next concept which I would like to explain is ionization constant and ionic product of water. Ionic product of water. Okay, right. So ionic product, what is this? Basically, whenever I speak about ionization, so we very well know, we have studied about the Bronsted-Lowry concept, acid base, conjugate acid and conjugate base. We will write in that term. I'll try to explain from that concept. Suppose if I have water, liquid, this is also combining with water, this one, here you're going to take it as base. This is acid. These two dissociate, and this particular thing from here, okay, this what did we say in Bronsted-Lowry? Electron pair acceptor, this one we already told you in Bronsted-Lowry concept. Whenever we are speaking about an acid, you need to speak acids or acids are proton donors and bases are proton acceptors. This is what we have put. Now this picks up, this becomes H3O plus. Okay, aqueous, and OH minus aqueous. So this is formed from this. So this is a conjugate acid. Maybe just not told, bases have like proton acceptors. This has accepted a proton. So this is conjugate base. Now I have to represent the dissociation K is equal to concentration of H3O plus OH minus product by reactant by H2O taken square. But we will very well know concentration of water is 1. So what will happen then? Only this is left, isn't it? K is equal to H3O plus and OH minus. This we are going to write it as KW, which is equal to H3O plus and OH minus. This KW is called ionic product of water. Ionic product of water. What is this? The value of KW at 298 Kelvin. KW is equal to, if I have right, H3O plus and OH minus, which is equal to 1 into 10 raised to the minus 7 second twice. It is equal to 1 into 10 raised to the minus 14. Concentration terms, isn't it? Mole per liter. So for both the concentration, 1 mole per liter, 1 mole per liter, and when you listen, take mole square liter minus 2, mole per liter, mole per liter. So this becomes mole taken twice and liter minus 1. So the most important thing you have to remember in ionic product of water, important points. Remember this when you are solving the numericals. What are they? First of all, KW is temperature dependent. It depends on temperature, if I have to speak. That means when temperature increases, Kw also increases, directly related. Right. So now if I have to speak using this concept, now you very well know for acidic solutions the concentration of H3O plus will be more than OH minus. For basic solutions the concentration of OH minus will be greater than this. For neutral solutions both will be equal. So what did it say? For acidic solutions, like if I have to speak in terms of ionic product, H3O plus will be greater than OH minus. For basic solutions, H3O plus will be less than OH minus. For neutral solutions, when I have to speak, H3O plus is equal to OH minus. This is what is a concept, isn't it? That is your ionic product of water. Nothing, very simple concept, isn't it? Yes. Well, let's come back and learn one more topic which is important in your ionic equilibrium, that is salt hydrolysis. Now basically, as the name suggests, a salt hydrolysis, that means when you dissolve a salt in water, it dissociates. But how does it dissociate? How does it get hydrolyzed? That is the important concept. You're taking sodium chloride, you're adding it in water, you're dissolving it. How is it dissociating? That is most important. Now suppose if I take a salt, right? Now salt is a combination, or it is formed by neutralization of an acid and a base. That means a cation and an anion. I'm going to combine a cation and anion. I'm taking this. Okay, right. Now this is your salt, ABA. I'm dissolving it in water. When you dissolve it in water, okay, equilibrium, yes. So what will happen? This breaks up. This is HOH, isn't it? Now suppose if you wish to take another way, not a problem. Let me write this BA. This will be better. H plus OH minus. So this combines with HA and OH combines with B. This becomes HA, not a problem, BOH. So this is an acid, this is a base. Correct? So salt plus water gives acid plus base. So hydrolysis process is a reverse of neutralization. That's why I should not write AB. It is a reverse of neutralization. Basically, acid plus base gives salt and water's neutralization. Salt plus water gives us acid plus base is salt hydrolysis. So I'm going to write this as, remember, reverse of neutralization reaction. Neutralization reaction. Simple, isn't it? Yes. Now in this particular thing, you have different types of salt hydrolysis. So now I'm going to write salt hydrolysis for this one. Okay, let us write what are the different types first which we have, then we will learn. You have salt of, again everywhere, salt of. What are they? Salt of strong acid plus strong base, one combination. If this is strong acid, strong base, the last one will be weak acid plus weak base. Now in between, this could be weak acid plus strong base. This will be weak base and strong acid. So either combinations, you can take another way. Now for such particular thing, so there is an important thing which you should remember. I'll write one after the other. Let us make how many? One. First with the nature of the salt. Second would be, the type of salt. This would be the nature. Then hydrolysis constant we will learn. Degree of hydrolysis we will learn. H3O plus we will learn. And pH value. Okay, let us write everything. Okay, lines are not straight, don't mind. This is the type of the salt. What is the type of the salt? The salt of strong acid and strong base. Example like sodium chloride, potassium sulfate, sodium sulfate, potassium nitrate, like KCl and all this. What is the nature of this? Nature, we very well know they are neutral. Hydrolysis constant for this? No. Hydrolysis constant there. Degree of hydrolysis? Degree of hydrolysis. No hydrolysis. H3O plus. No. Because this is a strong acid and strong base. How much will be the pH? 7. Perfect 7. Right? This is over. Now let us see the next combination, weak acid and strong base. Like your sodium acetate, sodium phosphate, sodium carbonate, potassium carbonate, like that. What is this? This is basic in nature. Because it is strong base, it is basic in nature. For this, hydrolysis constant formula would be KH is equal to KW by Ka. H is equal to root of KW by Ka into C. H3O plus formula for that concentration would be KW Ka by C. pH would be pH is equal to pKw plus pKa plus log C by 2. There is no place, that's why I am written there. Next combination is weak base plus strong acid. What is the combination here? Calcium chloride, aluminium chloride, copper sulfate, ammonium chloride, and all this. Because it is a strong acid, the nature would be acidic in nature. Here the formula of hydrolysis constant KH is equal to KW by KB, because it is the hydrolysis constant formula divided by same thing. You are writing for KAC, here KBC. H3O plus, same thing. Here instead of A you will write this KW C by KB. pH would be formula again, and there is no place, pKw minus pKb. I am just writing the formula here, minus log C divided by 2. This is in one line, I don't have place, I am writing it here. Right. The next one. The last combination is a combination of weak acid plus weak base. Nature would be, it may be acidic or maybe a basic or neutral. Hydrolysis constant KH is equal to KW by Ka into Kb. Next one, degree of hydrolysis, H is equal to KW by Ka into Kb. H3O plus would be, this is H3O plus concentration, KW by Kb. The pH value, okay, this is what H3O plus concentration. And the pH value, pH is equal to pKw plus pKa minus pKb by 2. This is your concentration. Now salt of weak acid and weak base. Okay, we said nature would be neutral. Then K is equal to Kb. If it is basic, Kb will be greater than Ka. And if it is acidic, okay, the same thing what I'm trying to say. In salt of weak acid and weak base, first important thing, if it is neutral, if it will be neutral when Ka is equal to Kb. It will be basic when Kb will be greater than Ka. It will be acidic in nature when Ka is greater than Kb. Hope you understood this concept. This is very simple. I have directly written the formulas, but when I do the numericals, I'll try to explain it properly. Let's come back and learn the next topic, that is buffer solution. So in buffer solution, what should you remember? You need to remember the definition. It's quite common. You need to remember the type, and you should also know the formula for calculating the pH of acidic buffer, basic buffer, and also know how to calculate the buffer capacity. Right. So whenever I speak about buffer solution, what is that? Which buffers are those which resist the change in pH value? Correct. That is what is this one. But buffer solution have a definite pH and at a specific temperature and does not change like on time. That's important. Now what are the two types of buffers? We have two types of buffers, that is acidic buffer and basic buffer. Right, you need to know this. So acidic buffer, what is acidic buffer? It is a mixture of weak acid and its salt with a strong base. What is acidic buffer? It's a mixture of weak acid and its salt with a strong base. And its salt with a strong base. What is basic buffer? Basic buffer is a mixture of weak base and its salt with, I'm sorry again, it's salt with, this is strong base, this is strong acid. Remember this. Suppose if I have to take the example of this, let me take one set. See, acetic acid, weak acid is acetic acid, and its salt, that is CH3COONA. Simple. Suppose if I have to take one example here, boric acid, and its salt of its strong base, isn't it? Na2B4O7. Here for this particular thing, the buffer pH will be almost 4.7. For this particular thing, the pH will be almost 8. Right? So that means for such solutions, for acidic buffer, pH, this is, let us write, this is one point, this is second point. For acidic buffers, pH will be less than 7. For basic buffers, pH will be greater than 7. Right? Now next important thing. So when I have to calculate the pH of the acidic buffer, and I have to calculate the pOH of the basic buffer. Right? So let us recalculate that. This is pH, this is called Henderson equation. Okay, let us write Henderson's equation. pH is given by pKa plus log concentration of salt by concentration of acid. What is Ka? Ka is a dissociation constant of the acid. The same thing if I have to write pOH for this. It is, here it is pKa, this will be pKb plus log salt by base. I very well know pH is equal to 14 minus pOH, or I can write in this term pH is equal to pKw minus pKb, this one, because 14 minus, this is pKb, the whole thing, plus log salt concentration by base concentration. So what is Kb? Kb is called the dissociation constant of the base. Done. This is your buffer solution. Now I have to learn about buffer capacity. Let us learn that also. Buffer capacity. So what is this buffer capacity? Basically, buffer capacity, why do we use now? If I have to take or consider the buffer capacity, learn the buffer capacity. Now I'll clearly know the for acidic buffer, how much was the pH value, how much was that okay, I'll try to explain what I am trying to tell you. Basically, buffer capacity is denoted by, this is equal to number of moles of acid or base added. Number of moles of acid or base added per liter of buffer. Per liter of buffer divided by change in pH. Change in pH. Remember this. Number of acid base added per liter of the buffer by change in pH. Okay, right. Now this buffer capacity, like when is this maximum? Buffer capacity is maximum. Suppose like buffer capacity is maximum. First condition, when salt concentration is equal to acid concentration, that is pH is equal to pKa for acidic buffer. Next, buffer capacity will be maximum when salt concentration is equal to concentration of the base, that is pH is equal to 14 minus pKb or pKw minus pKb. This is the concept. So when you do the numericals, you will understand what I am trying to explain you. Welcome back, students. Now I've already done the equilibrium chapter. I've given you different formulas related to that. Now let us start solving the numericals based on this. So this is your JEE Main Online 2013 question which is given here. Let us do this. So what did they give us? In the reaction, A plus 2B gives 2C plus D. The initial concentration of B was 1.5 times of A. Okay, the concentration of B was 1.5 times of A, means the B concentration was 1.5 times more than A itself. Done. Suppose if A is 1, this is 1.5 times, right? But at equilibrium, the concentration of A and B becomes equal. Okay, the equilibrium constant for the reaction is, that is what they are asking us to do. Let us try to solve this. First of all, whenever such question is given to you, try to copy the this equilibrium reaction which is given to you. So what is this? A plus 2B gives 2C plus D. This is what is the equation. Now what did they say? Initial concentration, how much do they give? Initial concentration is A is 1. So B is 1.5 times. This is 1.5. So then C was 0, D was 0. Then at equilibrium what happened? They said, but at equilibrium the concentration of A and B are equal. They said. That means this is already 1.5. That means a part of it has dissociated. Means X is the part of it which is dissociated. Then what will happen at equilibrium? This becomes 1 minus X, right? This becomes 1.5 minus 2x. Why? Because it is 2 moles here. And C will become 2x, D will also become 2x, right? This is right. Now I have to just say that both this and this will become equal, they said, isn't it? So no, this and this, A and B will become equal, they said. A and B will become equal. So now given as 1 minus X will become equal to 1.5 minus 2x. Correct? Now solve this. This becomes 1. This becomes 1.5 minus 2x plus x. X I've taken this side. Now when you solve this, x is equal to 1.5 minus 1, just 0.5. Correct? Now let's see. Now equilibrium constant for the reaction we need to calculate still. So equilibrium constant for the reaction, correct? How much is this? Kc is equal to products by reactants, isn't it? Products raised to the coefficient by the reactants. So how much is the product? This one given to us, that is C concentration D raised to 2 D divided by A, and B also was 2B, isn't it? B square. So how much is C? Which is, we have got Kc is equal to 2x square. D is how much? X. How much is A? 1 minus X. How much is B? 1.5 minus 2x. 1.5 2x, take whole square. This x is equal to 0.5. This is what it's got. Now we have got x value, isn't it? Now what should I find out? What did they ask? They asked me the equilibrium constant for the reaction, they said. Now let us substitute. X value is 0.5. Now substitute this value in this. Kc, already you've got x value. Now Kc is equal to 2 into 0.5 whole square, and x is this one divided by 1 minus 0.5, 1.5 minus 2 into 0.5x. So when I solve this whole thing, how much do I get? I get, when I solve clearly, like I get an answer of 4. This is the answer. So now what is the option given to us? The option given to us is B. This is the option. Done, isn't it? Now let's come back and do next question. So next question, what did they give me? They've given me, let us read. The equilibrium constant Kc for the reaction nitrogen plus oxygen. Okay, 2NO. I did a similar numerical earlier also. At the temperature T is 4 into 10 to the power of minus 4. The value of Kc for the reaction. So I need to find again equilibrium. This is a 2012 AEEE question. So as soon as such question is given to you, I said first try to write the equation which is given to you. Try to write that. Nitrogen. This is oxygen, which is gaseous state. This is forming 2NO gaseous state. This is the reaction. Equilibrium constant they need. That means Kc I need. Products by reactants. What is this? Product NO raised power, because this will become the coefficient, will become the power, isn't it? And this here is nitrogen, here is oxygen. Correct? Now How much is this? The value of Kc at the same temperature is, okay, fine. So now N2, how much at temperature T, they've given here, see here, the equilibrium constant Kc for the reaction N2 plus O2, that is this one, 2NO, right, at temperature T is, okay, and they've given 4 into 10 raised to the power of minus 4. This is equal to 4 into 10 raised to the power of minus 4. Right, fine. So now this is what is given to us. Now let us further solve this. Now when I have to solve, they have asked us a different concept here. What did they ask me? They asked me, well, this is given, fine, but the value of Kc for the reaction, for this reaction I need to find. Let us write that reaction. So for that reaction, okay, let us note that reaction. That is, they've given us NO, which is in gaseous state, gives me N2 gaseous state plus oxygen gaseous state. This is what is given to me. Now let us use a new this one, K prime C for this. K prime C is equal to, basically it is like products by the reactants only, isn't it? So let us write that, N2 concentration of O2 divided by NO. This one, right, how much is the balanced one? This is a 2NO, 2N, isn't it? This is square. How much is this if I have to write this in another term? K prime C is equal to 1 by Kc. Correct? Yes. So 1 by Kc. I can write that also in the early one. Okay, compared to that. So N2 and this will become 1. Kc, how much is this given to? We've got 4 into 10 raised to the power of minus 4. So this becomes equal to 10 raised to the power 4 by 4, isn't it? Yes, 4. Right. Next. Now let us come back to the reaction again. NO gaseous gives us half N2 gaseous plus half O2 gaseous. Why did I take this? Because they've asked to find at the same temperatures. Okay, right. So that is why I have taken that. So K prime, K double prime, say I'm taking one more, which is again equal to N2 raised to the power of half oxygen raised to the power of half divided by product. This is NO. Right, if I take, what is this? This is basically root K prime C. When I substitute the value, this is already your, this value given. That means it is root 10 raised to the power of 4 by 4. It is equal to 100 by 2, which is 50. Done. This is your answer. So the correct option for this is 50. This is the correct option given to you, right? So now after this question, what did they give me? Let us read one more question, right? In this question, they've given us nitrogen, hydrogen. Okay, they've given 1, 2, 3 sets of reactions. Okay, in this 3 sets of reactions, what should I do? I need to find the equation for the equilibrium constant of the reaction. Correct, right? So let's read the question first. So first reaction is given K1, okay, second reaction is again given K2, third reaction is given K3. So this is an online question, that is in 2013. The equilibrium constant, equilibrium for the equilibrium constant of the reaction, okay, they've given this and they're asking us to find out for this reaction. So this will be K4, isn't it? K4 in terms of K1, K2 and K3. I need to find K4 in terms of K1, K2 and K3. Remember that. Yes. So let us solve this question. So how should I solve? First of all, as soon as this question is given to you, you'll write in the required reaction. Okay. Let's see this again reaction. In this reaction, what is there? NH3 is present on the LHS. Correct. Now invert this reaction. Just this reaction, invert it in this way. Then what will happen if you invert this reaction, or I'm talking about here also, okay, same thing, right? So first, okay, if they ask me to write K4 in terms of K1, K2, right? So okay, we will start with this reaction. This reaction, NH3 is here, NH3 is here. I have to write this in terms of this, this in terms of this, this in terms of this. So make it equal, invert the first reaction. When you invert the first reaction, then what will happen? You will write it as, let us write the reaction, solution, first one you will get 2NH3 gaseous state, this becomes nitrogen gaseous plus 3 hydrogen gaseous. Done. Yes. So let us assume this is K5. Now we have inverted it, K5 is equal to 1 by K1, right? This is done. Yes. Now let us go with the next this one. Now there are 3 moles of water, isn't it? Here there are, in the next one, 3 moles of water here in this case, because I need to convert everything in this term, right? So what should I do? I have to take this reaction K3 and try to multiply with 3 moles. Then this and this will become equal. Let us take this reaction now. When I have to take the reaction, this is the first one. Let us take the next reaction. So when I multiply with 3, this will become 3 hydrogens. Then this will become 3 by 2 oxygens. Then this will become 3 water. So let us take this as K6, which is equal to, right, if I have to take, it is equal to K3, isn't it? Like that equation is K3, right, isn't it? By raised to the power of 3, because 3 we have done 3 times. Coefficient is that. Now next important thing, now when the reaction is multiplied by n, so n, K becomes K raised to the power of n, correct? Now let us come back to next reaction, N2 plus O2 reaction, this second reaction. This we have done this one. Let us come back to this. Now N2 and O2 reaction, 2NO, that's not a problem, that is directly K2. Let us write that K2. So now let us pick that third reaction, that is N2 gaseous plus O2 gaseous gives, it is an equilibrium with 2NO gaseous plus, okay, gaseous, that's it, isn't it? And this is your K2. Now what are we going to do? Let us take this, here already these reactions are 1, 2, 3, isn't it? 3. So let us take this as 4th reaction. Let us take this as 4th reaction. Let us take this as 5th reaction, right? So now what am I going to do? We are going to add equations 4, 2 and 5. Okay, 4, this is 2, 4, 2 and 5, all these 3, because I have modified it, isn't it? So when I add this, and what do we get? Just add and see and cancel the common terms. 3H2 gets cancelled here, right? Then what are we left with? NH2, 2 NH2 is here, so let us write that 2 NH3 gaseous. Okay, this and this got cancelled. Okay, nitrogen on this side gets cancelled, so hydrogen also got cancelled. So what are we left with? We are left with 3 by 2 oxygen, which gives, on this side let us see, 2NO, correct? Yes, and 3 water molecules, because this and this got cancelled, isn't it? So we got 3 water molecules. This is gaseous, this is NO is gas, this is also gaseous state, correct? So let us see this. Now K4 is equal to K2 into K5 into K6. This is the thing. Now let us put the values of this. K4, when I write in terms of that, what K2 was K2 only here. K5 was, what is K5? Basically it is 1 by K1 into, what was K6? K6 was K3 is power of 3. Correct. Now I need to write in terms of K4. Let us write. K4 is equal to, K2 is still here only, into 1 by, okay, I can directly write, isn't it? It is already over. So I'll write it as K2 into K3 divided by K1, K3 cube. So this is your simple, isn't it? I just converted based on that and I got. So for us here the answer is K2 into K3 cube divided by K1. Let us see the option. K2 into K3 cube by K1. D is the answer, right? Hope you have understood this son. If you have not understood, please give your comment in the comment section. Now let us see the 4th question. So in the 4th question, what do they give me? They've given me, this is again JEE Main Online 2013 question. Let us see. So they've asked us the ratio of Kp by Kc for the reaction. So this reaction is given to me. The ratio of Kp by Kc I need to find. Already we have studied one formula for this. What is the formula? Kp is equal to Kc into RT Ng. This is the formula which you have learnt already. Now for this reaction we need to go with the coefficients. Let's see. So for this reaction, Ng, delta Ng, okay, is equal to 1 minus 1 plus half, plus minus product by reactant, and A by B is A minus B. We've written which is equal to minus 0.5. Now let us put the value of delta Ng value we've got here. Kp is equal to Kc RT minus 0.5. Right. So when I have to write this, Kp is equal to Kc root RT. I can write like this also, isn't it? Yes. So now the second step, I can also write this as Kp by, I'm getting this down, Kp by Kc, because they've asked me the relation of Kp by Kc. So I'm getting this down. Kp by Kc is equal to 1 by root RT. Right. This is the sum. So what is the answer? 1 by root RT. So Kp by Kc is equal to 1 by root RT. The correct option is A. That's it. Simple. So in this Ionic Equilibrium question, they've asked us, let's see this. How many liters of water, okay, how many liters of water should be added, they said. Right, I can start this equation. First, pH1 is given to me, pH2 is given to me. So let us write this. Individually, for pH1, pH is equal to 1, right? So how much is a H plus ion concentration for pH is equal to 1? It is equal to 10 raised to the power of minus 1. It is equal to 0.1 molar, right? A negative log of a H plus ion concentration, isn't it? Which is raised to the power 10. Now if pH is equal to 2, then H plus ion concentration is 10 raised to the power of minus 2, which is equal to 0.01 molar, right? Now they were asked us how many liters of water must be added to 1 liter of aqueous solution of HCl, they said. That means for dilution of HCl, M1V1 is equal to M2V2. Correct? Yes. So how much is M1 now? 0.1. What is the volume of this? 1. Because 1 liter they were said. What is M2 now? M2 is 0.01. What is the volume of this? I need to find, because I need to find that how many liters is it. So V2 I need to find. It's easy, isn't it? V2, if I solve, I get 10 liters. 10 liters. But now volume of water to be added, because total quantity of water this one, isn't it? So volume of water, because they've asked how much must be added to 1 liter, they said. Okay, volume of water to be added, this becomes 10 minus 1, that is 9 liters. So the correct option is 9 liters, right? Right. Now let us see next question. Here what do they give us? In ionic equilibrium, basically what would be the pH of a solution obtained by mixing 5 grams of acetic acid and 7.5 grams of sodium acetate and making the volume equal to 500 ml, they said. Okay, they've given us Ka and they've given us pKa value, both the values. So this is your 2013 online exam question, and they've given us 4 options. Now I have to find what would be the pH of the solution, right? So to solve such questions, first important thing, you need to remember the formula. Okay, in simple formula, basically what is that? Concentration is equal to mass by molar mass into volume in ml. Correct. Now let us speak in terms of acetic acid. Now I'm going to talk about acetic acid. So in acetic acid, how much is this in concentration here, mass of this? They've given 5 grams of acetic acid. 5 grams. How much is the molar mass? 60. How much is the volume? They said it is and making the volume equal to 500 ml. They said so 500. When I solve this, I get an answer of 0.166 molar. Now same thing, let me find for sodium acetate. So similarly for sodium acetate. So for sodium acetate, again the same thing, like mass by, okay, mass by, and did we multiply with 1000? We didn't multiply with 1000. I need to multiply with 1000 also, isn't it? 5 grams into 1000. Okay, same thing here. Mass by molar mass into volume in ml. So CH3COONA, how much is the mass? Given 7.5 into 1000 divided by molar mass is 82 into 500. Now I get an answer of 0.183. Okay, right. So now they asked now for the buffer of this one, I need to find the pH, isn't it? So for the buffer of CH3COOH, okay, minus, we have done salt of weak acid and weak base, and it's salt of weak base, so CH3COONA. Now pH is equal to Ka plus log of CH3COONA. This formula also we have studied, CH3COH. How much CH3COONA we have got? We have got this one is, okay, let us start from here. pH is equal to, how much is pK which we got? 4.76 into log, how much is it? 0.183 molar. And for acetic acid it is, we got 0.166. When I solve this, I get an answer of 4.80. That means your 4.76 is very much less than pH, is very much less than 5. This is what is the option. Means our answer lies at this option. And answer lies in this option. This option. So the correct answer is this. Now let's come back and do one more question. So in this question, let's do this. Very interesting question it is. They've given us a 25 degree solubility product question basically. So earlier we have done solubility product formulas also. Let's read this. This is your 2010 paper. So here what did they give us? Solubility product at 25 degrees, the solubility product of magnesium hydroxide is 1 × 10⁻⁻11. At which pH will magnesium ion start precipitating in the form of magnesium hydroxide from a solution of 0.01 molar magnesium Mg+2 ions. Okay, at which concentration, at which pH I have to find? I need to find this pH. So as soon as such question is given to me, I said try to write the equation. And what is this? Magnesium hydroxide breaks up into Mg+2 plus 2OH minus. So now what is the solubility product formula? KSP is equal to magnesium plus 2 and OH minus, over 2OH minus. So I need to find for this, isn't it? Okay, let us take this out. So OH minus is equal to square root of KSP divided by Mg plus 2 ion. How much is this equal to? This is equal to 10⁻⁻⁴. Right? Done. So now I should find for POH also. Okay, let us write this. POH is equal to 4. And what did I get? pH is equal to 10. Isn't it? Let us see this. POH is equal to 4 and pH is equal to 10. So what pH they said? B is correct option. Yes, because they've asked me to find the concentration. Okay, I did it. Yes, it's right now. pH in the form of a magnesium hydroxide for the solution 0.01. Right, this is the answer. Let us do the 8th question now. So in the 8th question, what did they give me? They've given me values of dissociation constant. Ka is given as follows. They've given this values. Now this particular question is given in JEE Online 2013. They've given values for acid and they've given their Ka values, acid dissociation constant values, right? So now the correct order of the basic strength of the base Cn minus, F minus and NO2 minus will be. They've given us option A, option B, option C and option D. I need to find the correct order of the basic strength. So you have such questions based in like for you in this one also, inorganic chemistry, find the order, increasing order, decreasing order, and all this. So when such question is given to you, let us learn one important thing. What is that? First of all, acidic strength, we already know this. I'll speak in terms of this one, then come back to that. Acidic strength is directly related to Ka value. This is understood? Yes. Now on the basis of Ka, if I have to take, the order of acidic strength would be HCl less than HNO2 with this basis, because if I see the readings, right, directly related I said. So HNO2 has HCl less than this, then HNO2, yes, then comes HF. This is a concept. Now conjugate base of a strong acid is weak. This is what we have studied in Bronsted-Lowry concept also. What do we learn? We have learned conjugate base of a strong acid. Strong acid is what? It is weak. Now what if I have to write the order now? Yes, conjugate base of the weak acid. So this becomes F minus less than NO2 minus less than Cn minus. This is the option which you get. So the correct answer is F minus less than NO2 less than Cn minus. So this is a concept. Yes, if you have not understood this concept, I did in the formulas, ARENES concept, Lewis acid concept, Bronsted-Lowry concept. Watch that please. Yes, let's come back and do the 9th question. Now in the 9th question, what did they give me? This is again JEE Online 2013 question. So they've given us the reaction A plus 2B gives 2C plus 2D. Okay, so 2C plus D. I think I've done this question already. So let us take this question out and come back to, because the same question is repeated in another lesson also. Let's do this. Right. In the 10th question. 10th question, what did they give me? Now the KSP, again a solubility product question is given to us. So now solubility of chromium OH taken thrice. They've given us chromium complex solubility is 1.6 into 10 to the power of minus 30. Okay, right. And then the molar solubility of their compound in water. What is the molar solubility of the compound in water? They've given us A, B, C, D options. Right. Now let us see for this one. This is chromium, calcium hydroxide. Let us see the solution for this. I need to find the molar solubility of the compound. Okay, let me see whether I can do it like this. So calcium hydroxide solid, it dissociates when you dissolve in water into no, this is chromium only. I'm sorry, because then only plus 3. No, I'm sorry. This is here plus 3 aqueous. I'm really sorry for that. Plus 3 OH minus aqueous. Okay, sorry to confuse you all. Right. Now this is the molar solubility denoted by S. This is also S. This is 3S. Now KSP is equal to concentration of Cr plus 3 OH minus taken thrice. Now write in terms of that, how much is KSP given to you? It is 1.6 into 10 to the power of minus 30, which is equal to, how much is chromium this one? According to this is S, isn't it? Yes. This is 3S whole cube. So this becomes 1.6 into 10 to the power of minus 30 this cube. Okay, 27 S to the power of 4, isn't it? This is 4. Done. Now S to the power of 4, S4 is equal to 1.6 into 10 to the power of minus 30 by 27. This is equal to, this becomes 4 root 1.6 into 10 to the power of minus 30 by 27, minus 30 by 27. So this is the thing. So where is the answer? This is 4 into 1.6 into 10 raised power of minus 30 by 27. This is the correct option. Right, let's come back and see next question. This is a 2012 AEEE equation. The pH of a 0.1 molar solution of the acid HQ is 3. Okay, pH is 3 it seems. The value of ionization constant Ka for this one for the acid is, they've given us again 4 options. You need to find the correct. So what should I find out? I need to find Ka for this, for HQ, that is all this. So first of all, as soon as this is given, just write HQ dissociates into H plus and Q minus. I need to find what ionization constant Ka. Okay, so let me write H plus is equal to root Ka by C. This is how did I get this? This has come from Oswald Dilution Law. Why did I take this? Because I need Ka dilution law. Correct? Yes. Now we very well know H plus is equal to pH, okay, our 10 raised power of negative logarithm of H plus ion concentration, correct? How much is this equal to? That thing they've given us 10 raised power of minus 3. I can write this, pH is equal to negative logarithm H plus base 10 I can write, right? So this is the thing. So now what is pH value? 3, because they've given 3 times, minus 3, correct? Right. So now what is the concentration? How much is C? How much is C given? C is 0.1. Okay, 0.1 molar. Substitute in this formula. If I substitute in this formula, what do I get? I get 10 raised power of minus 3 to Ka into 0.1. I need to find Ka. This is root, which is equal to 10 raised power of minus 6. Root I have taken out, Ka into 0.1. So Ka, if I take this out, Ka is equal to 1 into 10 raised power of minus 5. So this is correct answer, right? Simple. I got from Oswald Dilution Law. So the correct option is 1 into 10 raised power of minus 5. Yes. Now, hope you are understanding this. I'm going a bit slowly so that you will all understand and keep practicing it on a regular basis. I'm just doing and just uploading, but if you practice from your side is very important because the time is very less for you all. Right. Let us see the 12th question. So in this 12th question, what did they give me? Solid barium nitrate. Okay, right. So solid barium nitrate is gradually dissolved in 1 to the power of minus 4 sodium carbonate solution, at which the barium precipitate Ba+2 precipitates of barium carbonate begins to form. Okay, so the KSP of the solution is, right? So here the KSP for barium carbonate is given 5.1 10 raised to the minus 9. So here this particular question is AEEE 2012 question here. So now they've asked me to find for what I need to find at which concentration of Ba+2 precipitate. Okay, I think I've done the same numerical earlier also, the same concept also was done, but for that I'll be doing it again. Let's say this solution. First, concentration of carbonate is how much? Concentration of CO3 is how much? Ions is 1 into 10 raised power of minus 4 molar, right? For something to precipitate, KSP should be less than or equal to concentration of barium plus 2 and concentration of CO3 minus 2. This is what we studied earlier. So how much is KSP given? 5.1 into 10 raised power of minus 9. Correct? Now minimum concentration of barium should be, they've asked me, minimum concentration, hence minimum concentration of Ba+2 ions should be Ksp by CO3 minus 2. Ksp, how much? 5.1 10 to the minus 9. How much is equal to 1.0 10 to the minus 4, which is equal to 5.1 into 10 to the minus 5 molar. This is the thing. So 5.1 10 to the minus 5 molar. This is the correct option. Right. Now let us see the next question. An acid HA ionizes as HA gives H plus plus A minus. The pH of 1 molar solution is 5. Okay. Its dissociation constant would be. This is again AEEE 2011 question. Dissociation constant is asking us to find out from these 4 options which are given to us. Correct. As soon as such question is given, same thing. Write the reaction. Okay. Right. So how much is this? As T is equal to 0, this will be 1. How much the concentration will be? 0, 0, because the reaction is not yet started. Now at T is equal to T, that's a particular time. How much is this? This is the concentration. Okay, they said the pH of 1 molar solution is 5, they said. That means 1 minus 10 raised pH negative logarithm, I can write it as 10 raised to the minus 5. This will be 10 raised to the minus 5. This will be 10 raised to the minus 5. Right. Now, concentration of H plus, A plus is equal to concentration of H plus. Now, I need to find Ka. K is equal to product by reactant, concentration of H plus divided by A minus by H. How much is H plus given? 10 raised to the minus 5. This is again 10 raised to the minus 5. H is 1 minus 10 raised to the minus 5. So now let us write this. 1 is very much greater than 10 raised to the minus 5, isn't it? Yes, when I compare these. That means what can I do? I can write this whole thing as 1 minus 10 raised to the minus 5 can be written as approximately 1. Then what will Ka be? If I solve this, K will be 1 into 10 raised to the minus 10. So this is answer when I solve this. Correct? Yes. Hope this is clear, because how did I get 10? This is your 10. This is 1. 1 into 10 raised to the minus 10 is the option. This is the correct answer. Yes. So hope this is clear. Let us come back and do one more question. I'm trying to do all types of questions here. Let's see. Oh wow, such a big question. Right. What do they give us? Which of the following arrangement represents correct order of solubility of sparingly soluble salt? Right. Here they've given us correct order of solubility. They asked us, and they've given different options. So let us see what to do with this. Correct sparingly soluble salts of mercury chloride, chromium sulfate, barium sulfate, and chromium chloride. I need to find the correct order of solubilities of these. So when such question is given to you, what should you do first? First, try to pick up one and find out how. I'll tell you. See here. The first thing you need to do is pick up one. I said first thing. Let us take the first one. Hg2Cl2. This will break up into Hg plus 2, Hg2 plus and 2Cl minus. This is S1 mole per liter. This is also S1. This is also S1, but this is 2S1. So Ksp we need to find Hg2 plus 2 and Cl minus 2. Now how much is Hg plus 2? This is S1. How much is Cl? It is 2S1 square. So when I take this, I get this is equal to 4S. This whole thing is equal to S1, isn't it? This S1. How much is this coming to? This comes to 4S1 square, which is equal to 4S1 cube. So solubility I need to find. Now solubility is equal to S1 is equal to KSP by 4 1 by 3. This is how you need to find. Now let us find for the next one. Chromium sulfate. This will dissociate into 2Cr plus 3 plus 3SO4 minus 2. Now same thing, this will be S2. This will be 2S2. This will be 3S2. Right? So when I solve this, this becomes 4S2 into 27 S2 taken thrice, which is equal to 108 S2 taken 5 times. So for such thing, S2 is equal to KSP by 108 raised to 1 to the power of 5, because 5 is here. I'm finding for the third one, same way, like that only. Barium sulfate, this dissociates into BAA plus 2 plus SO4 minus 2 ions. Let us divide this page. I will not find place again. Right. So for this, what is barium sulfate here? How much is given? S3 mole per liter. This is again S3. This is also S3. Now KSP is equal to the concentration of the barium into concentration of this, isn't it? These two concentrations together. How much do I get? I want to get S3 square. This is over. Let us do for fourth one, chromium chloride. Chromium chloride dissociates into Cr plus 3 Cl minus. How much is chromium chloride? Here this is S4 mole per liter. Cr plus 3 if I have to take. I'll take S4. This is 3S4 because 3Cl minus. So if I find KSP, this into this, this into this, isn't it? This becomes S4 into 3S4 whole cube. This answer comes to 27. Let me write this here. This comes to 27S44. So KSP, okay, S4 is equal to, or solubility is equal to, S4 is equal to, now this is S1 which we found out, this is S2 which we got, this is if I have to take, this is S3, okay, already there, isn't it? If let me write that. S3 is equal to KSP half. Okay, S3 is this, S4 if I have to write, KSP by 27 1/4. Okay, right. So this is how you have to solve everything. Which is the option KSP by 4 1 by 3, KSP by 4 1 by 3. So KSP 108.05, this one. So the correct option is the third option which we have got. Okay, let me see this also. KSP half, okay, this one. Next, KSP by 27 is what we have got. That also is right. The correct option is D. Let us come back and do next numerical, 15th numerical. So sodium hydroxide is a strong base. They've given this strong base which will be at the pH of 5 into 10 raised to the power of minus 2 molar sodium hydroxide. Log 2 is equal to 0.3. Okay. Now here they've given this numerical. Let us see how to solve this. They've asked me to find out what sodium hydroxide, what will be the pH, they asked me. Okay, so basically when such numerical is given to you, you can start solving the numerical like this. 5.0 into 10 raised to the power of minus 2 molar sodium hydroxide is equal to concentration of OH minus, how much is equal to, okay, it is equal to how much? Okay, the same thing. It is basically, it is equal to 5 into 10 raised to the power of minus 2 molar. Correct. Now we very well know H plus ion concentration into OH minus ion concentration is 1 into 10 raised to the power of minus 14. So how much is OH minus now? This one. So H plus into 5 into 10 raised to the power of minus 2 is equal to 1 into 10 raised to the power of minus 14. Find out H plus, because that is what I need to find. H plus is equal to 1 into 10 raised to the power of minus 14 divided by 5 into 10 raised to the power of minus 2. this comes to, that's it. But still I'm not done. pH is equal to minus log of H plus. What is this? Minus log. What is the H plus concentration we've got? 2 into 10 raised to the power of minus 3. Is it minus 3 or minus 13? 12, no, this is 13. Yes, minus 13. So approximately they've given log 2 value here, which is 0.3 they've given. So when I solve this, I need to, I've already shown in the log table like that day how to see. So log 2 given already. When I do this, we'll get 12.69, which is approximately 12.70. So the answer is 12.70.